have Erika Boeing, founder and CEO of Accelerate Wind. Join me in welcoming her to the stage. Erika is working with Dr. Aaron Greco at Argonne National Labs, developing an integrated small wind technology for deployment on commercial buildings. Accelerate Wind is going to blow you away. Erika, please.
Cool. Hi guys, I'm Erika Boeing, founder and CEO of Accelerate Wind, and we're developing an affordable distributed wind energy technology. So the renewables industry has been thriving recently. Utility scale solar, rooftop solar, utility scale wind, all had multiple gigawatts of installation in 2018. Distributed wind or rooftop wind, however, didn't have nearly the same success, with only 4.3 megawatts of installation in the past year. And the main reason for that is cost. Distributed wind turbines today are just way too expensive, oftentimes not even paying themselves back within their lifetime. And as you can see from this chart here, that cost is a mix of hardware costs and soft costs, things like customer acquisition, installation, and permitting. And so any solution that really takes the cost down to where it needs to be needs to look holistically at both of these things. And so that's what we've done at Accelerate Wind. We're designing a rooftop wind turbine that reduces cost in 3 ways. First, we're reducing soft costs by selling to solar installers. Second, we're using edge-of-roof wind capture. And third, we're using intermediate storage in our powertrain. And I'll walk you through what each of those means now. So the first thing that we're doing is we're selling directly to solar installers so that we can take advantage of their decades worth of experience, reducing costs for these things like customer acquisition, installation, and permitting. And we've talked to over 100 solar installers to make sure that we really understand their needs, and we found that they're really enthusiastic about a rooftop wind solution such as ours because it allows them to diversify their product offering in a market that's traditionally had a lot of ups and downs. They're already selling things like batteries today to address the same issue and are really excited about a solution like ours that fits into their existing installation practices. The other great thing about selling to solar installers is that the majority of commercial buildings can't produce their entire energy demand from solar alone. And so we offer them an ability to add on about 30% additional renewable energy in addition to their solar installation. One other awesome thing about selling to solar installers is that they typically don't install on the edge of the roof. And one of the reasons for that is it's too windy, which leads to our next differentiation. So the next thing that we're doing is we've designed a wind turbine that takes advantage of the fact that wind speeds at the edges of roofs are naturally much faster than other parts of the roof. You can see in this computational fluid dynamics model here, in red, the wind speeds going through that channel are about double the wind speeds in the ambient wind. And we've, through extensive CFD modeling and work with scientists at Argonne National Lab, found a way to predictably and reliably channel that faster wind to a central wind turbine, allowing us to produce 3 times the power of existing systems. We built a prototype of this unit that we'll be installing on the roof at Argonne National Lab within the next month. So technical performance of this is important, but as we've done our modeling, we've also found that there's a number of different designs aesthetically that have the same technical performance. And so at the same time that we're testing our prototype of the system, we're also testing these aesthetic designs with building owners, architects, and structural engineers to make sure that we're really designing something that people are excited about putting on their buildings. And that's seeming to make a big difference. The third and final piece of our technology is focused on something the other 2 pieces don't do, which is reducing the cost of the expensive generator and inverter. So with our patent-pending drivetrain technology, we couple a flywheel to the wind turbine rotor. And this lets us store energy during high wind speed gusts and release it during lower wind speeds, letting us size down the generator and inverter to be much closer to average wind power rather than peak. This lets us cut the cost of the entire powertrain about in half. We built a prototype of this system as well and are testing it with real rooftop wind speeds from the roof at Argonne. So what do these 3 strategies together look like? We mentioned before that the cost today is about $5.48 per watt. Using our patent-pending drivetrain technology and our solar-like infrastructure costs, we're able to cut that about in half. And then when you add on the edge-of-roof performance advantages, we cut that about in half again to $1.86 per watt. And we've tested this number over and over again with solar installers and potential customers to make sure that it's something that they're interested in, and they've all verified that this is really a cost that we could go to market and scale with. Not only does the cost make sense, but the market's sizable. So as an add-on market to new solar installations, this is about a $1.8 billion market in the US today that's growing at an 18% CAGR. We've been building relationships with solar installers in Illinois specifically, so we plan to start there, which is about a $15 million market for starters. We also have a great team behind the technology. So this technology itself comes out of my experience as a Fulbright researcher in the Netherlands and builds off of 9 years of experience developing new energy technologies. My teammate Scott has 13 years of experience building up robotics projects and working in hardware startups. We also have an awesome team at Argonne and at Illinois Institute of Technology with experts in wind turbine reliability, wind prediction and modeling, and generator and power electronics design. So since we started, we've raised about $800,000 in non-dilutive funding, and that's allowed us to really prove out our prototypes and develop something that we're confident will be low cost, robust, and reliable. Over the next couple of months, we'll be continuing to iterate these prototypes, and in early 2020, we'll be raising a seed round to evolve these prototypes to the pilot stage. So we're seeking connections to investors, pilot partners, and business and manufacturing talent that will really let us get to the next level. So if that's something you'd be interested in or have connections for, please come see us at our booth, and I'd love to tell you more. Thanks.